One man. One star. The Daily Space Weather. And thanks for tuning into the Smash News Network, the busted name of news. Congratulations on realizing the channel exists. We're delighted to have you and to bring you the world's most comprehensive daily space weather and detailed solar imagery. So we thought that was an earthly directed CME, and well, there still is a small component of that likely to strike Earth, just like we said this morning on the 17th. However, it's gonna be pretty minor. So we'll show you more evidence of that momentarily. We'll give you a breakdown of that and talk about all the goings-on for the past 24 hours, hence the term Daily Space Weather Show. That's why the show's called what the show's called. And if you look down here south of our Earth scale, right in here, there it goes. Some of that plasma reoriented and just deposited at a different spot on the sun, succumbing to gravity. Other portions of that filament blasted off into the greater solar system. Part of it is headed toward your back door. And don't allow cult leaders to make it in your back door. They may set up camp and become a squatter in your family room. Let's hope not. Watch out for those doggone cult leaders. They will be expecting handouts. Now what we're showing here is this is 304 angstroms, 60-minute running difference. That's ionized helium, and then the 193 angstroms. Another wavelength from SDO there. That's ionized iron in the raw imagery. So yeah, it's an exciting time to be doing space weather as we see another large ramp up in sunspot number. We'll talk about it and plenty more. Here's our SDO colorized magnetogram, and we can expect another uptick in sunspot number going into tomorrow. So now, if you're one of those people who's spooked of low sunspot numbers, now you should feel safe because we have high numbers of sunspots. So if you're worried about not enough sunspots, you can stop worrying. If you're spooked of a lot of sunspots, now is your time to be spooked. Trade off the bunker. Trade off the bunker. So grand solar minimum people, you can come out of the bunker. Spooked of stars people, you go into the bunker now because we're getting up toward 150 sunspots. So that's just a little update on what to be spooked of if you don't understand things like space weather and basic physics and how to forecast things. So it's still light out in Iceland, although it is getting dark there now, as the only active cinder cone there still associated with some lava flows there, but it's it's chilling. It's chilling. It's a good time to go check it out. Although definitely don't fall into one of those ice calderas. I mean, what is it called? An ice cauldron. Because a lava tube can sometimes fill up with snow as a result of glacial runoff and fill up with ice and so on, and then it can melt and you can fall into it, and it's not optimal. It's suboptimal. There are all kinds of hazards that you may not be familiar with if you're not used to being around volcanoes. So don't pole vault the caldera. I'll just say that. What else is erupting, you ask? Abico, Luatobi, Luatolo, Semeru, Merapi, Dacono, Sancho Guido, Fuego, Nevado del Ruiz, Revenador, and Sabancaya. These are the earthquakes going off for the past 24 hours, and activity is low. I don't care what Dutch Sins said about it. I mean, you can go around every active fault line in the world and say an earthquake's going to happen on one of these active fault lines, and you'll have, quote, forecasted by saying that. These are the quakes of a 5 and greater magnitude. There is a 5.3 in the Mid-Atlantic Ridge, just north of the equator there in the Tropic of Cancer. So it looks like only one 5 magnitude quake over the past 24 hours. Like I said, very low levels of seismic activity. And we'll get back to some more space weather stuff here first. Let's get back to some solar imagery. DAG. It's here at the Smash News Network. We like bonkers imagery. So here it is. How you like them apples? So these are 24-hour videos at 30 frames per second. That's SDO 171 angstroms, 171 ionized iron. It's iron 9? think it's iron 9. And it depicts the lower corona and the magnetic fields associated with active regions very well, as you can see. Also filaments as they extend hundreds of thousands of kilometers into the corona. Here we've put a bar scale there for you so that you can see the size of filaments. There's one setting in the southwest. And if you're not familiar with kilometers, well, here's the Earth scale on the exact same imagery. For your viewing pleasure. Yes, they're big. That's about 500,000 kilometers in length, most likely there. That filament, if you measure it in the longest wavelength, it doesn't even fit on that massive frame that we've put together. Stars, they're big. And by the way, that's why we take exception to the term micronova. That's an idiotic term. Let me talk micronova for a minute. Micronova is an idiotic term. Why? Because it's a reference to a star having like a star-wide eruption, like a CME that comes out in all directions, or even if it's just on the equatorial plane or just out of the poles or something, that would be what we call a nova event or a noval event. We don't call it a micronova because stars are big. So saying there's nothing micro about it. How is it micro? It's not micro. It's a nova. It's a specific type of nova coming from a specific star. They're all different. They all have their own signature, and they're all vastly. It's like a fingerprint, a stellar nova. And so that's why I refuse to use the term micronova. It's just an indication that somebody's just saying things, just throwing words at the wall and hoping something sticks. So here are these new active regions there rising in the southeast. That's pretty sweet sunspot there. I mean, we've also got some... Oh, hold on a minute. We've oh geez, we've also got some properly massive features up there, and oh man, I broke my pause button. All right, that's okay. We make these videos like a live stream anyway, so that was my oversight as I optimized for streaming earlier today. We've got these new sunspots up here in the northeast and in the southeast, and I just wanted to highlight this massive multi-100,000 kilometer in length magnetic filament, that huge plasma filament up there, as a lot of material is defying the sun's massive gravitational fields by succumbing to massive magnetic fields. So that's an unsustainable situation right there, folks. That filament will either collapse, relocate, or blast off and become a CME. Those are the choices. And let's cut to more stuff. More stuff like the 10.7 centimeter radial flux, which is, I think, still at 161. 161 solar flux units is the radial flux number. So here is there's a 1 year graph of it to contextualize it. 161 looks like it's flat since yesterday. And by the way, we're expecting geomagnetic storm conditions tonight. So a mild geomagnetic storm likely tonight, more likely tonight than it was last night. So if you didn't see yesterday's space weather show, I don't know what to tell you. But today's we're saying the same thing as yesterday. Sometimes I have to tell people, if you ask me the same question twice, you're going to get the same answer twice, unless I have different information or something. So anyway. So yeah, expecting mild geomagnetic storms tonight from a CME impact. Also possible coronal hole influence, but a CME impact. So here's NOAA's Enlil spiral, and as you can see there, 14th into the 15th. This way, if the internet goes down, of course, you can file for a tax extension and claim that it was the sun that caused you to pay your taxes late. or perhaps have your own money returned to you and then celebrate it because you don't understand basic economics and you think that it's some kind of a bonanza. A bonanza, getting a tax return. That's the government borrowing your money all year and then paying it back. And folks, everybody should just file quarterly taxes and just have your own escrow accounts that, bear interest. I don't know, bond funds, something boring. Anyway, this is ESA, European Space Agency's forecast, and they are expecting CME impact like midday tomorrow, it looks like. So a little bit different than NASA's forecast, and I was off for the day when this CME happened, so I don't have a forecast. I'm just relying on them and what Tamitha Skov says on Twitter and things. So if that's insufficient for you, then too bad. Don't like it? Make your own space weather show. That's what we did, because we certainly didn't like the crap coverage of daily space weather content on YouTube. So anyway, here are the past 4 hours of Earth's magnetic moment from space, and it's very calm. So is it the calm before the geomagnetic storm? Is that enough to get you in your bunkers? Let us know in the comments. And here is our ground magnetic perturbations map. The same period of time. If you know, it's ground magnetic perturbations. It's a good way to figure out where you might be able to see the aurora. And I suspect you'll be more likely to see it in places like Iceland, especially just before sunrise, when the electrons are fluxing, when there's a better flow of... All right, Anyway, let's move on to the KP index. KP1 is the current situation. It is geomagnetically calm. The ACE is showing a slow and diffuse solar wind at under 400 kilometers a second at 364. Very diffuse, only about a third of a proton per cubic centimeter. It takes 3 centimeters to see 1 proton where the ACE is located. Now the Discover is much denser, as usual. Almost 3 protons per cubic centimeter. So, and right around 400 kilometers per second. So that is, if that's a CME impact, that's a weak one. And that is definitely not going to be, that is not going to cut it for creating geomagnetic storm conditions. So far, the ghost magnetometers are chilling. And to quote Mark Rebier, what the f are you doing if you're not chilling? Next is our top view ecliptic plane field plot. And last I checked, Earth is solidly in a South Pole oriented sector, and that remains the case. So it's looking a little bit more consistent there to our east. For the coming days, expect to be in a South Pole magnetic sector. And if you think that is like affecting your migraines or something like that, please don't. You can't measure it from the ground level in terms of its magnetic fields. You have to use light polarization, and it's not, the magnetic sector is not affecting your migraines or your psychosis. So here's our line of sight field plot. Because keep in mind, folks, that's not measurable from the ground level. So the magnetism of the heliospheric sector, it's not directly affecting you. It's putting a tiny difference in pressure on like the outer portion of the ionosphere and things. The exosphere, as it were. So here's our line of sight field plot, and that's a lot of information. And B field, photosphere, magnetism, and polar fields all shown at once. Here's just our coronal hole line of sight plot. And like we've forecasted, South Pole oriented coronal holes showing up with that South Pole oriented sector, since the coronal holes are effectively the polar fields as they migrate, which is what a solar cycle is doing. As the polar fields migrate from the poles across the equator back to the opposite poles, that's what a solar cycle is. And it is possible that the polar field reversal drives the sunspots and not vice versa. We ultimately don't know. It's a chicken or egg argument. And we just simply don't know if the coronal holes and the polar field reversals are in charge of it, or if the sunspots are in charge of it. So let's take a look at coronal holes from SDO. There you go. And those coronal holes just below the equator there in the east are gaining some definition there, either just because of perspective or because they're kind of opening up or perhaps migrating. But we can expect that to be geo-effective there. That could affect Earth for quite a few days, as I expect there to be a high-speed wind in there. So that is likely to be geo-effective, and it could be quite significant because, well, frankly, we've seen pretty weak coronal hole activity throughout solar cycle 25 so far. Moving right along to sunspots. Those are a thing. And like I said, sunspot number here is approaching 150. So sunspot number is about 138 right now. 138 sunspots is a sunspot number. And the flare monitor there is showing the most likely place to see a large flare is sunspot 3634. So the upper right, your northwestern limb way over there. And showing considerable magnetic complexity there. And as it gets closer and closer to the limb, yeah, don't be surprised to see an MRX class flare come from that sunspot, as you can see on the flare probability scoreboard. So let's do a brief coverage of cosmic rays here. We haven't done cosmic rays for a little bit too long, so we'll briefly cover cosmic rays. And then we'll come back and look at sunspots from SDO. So cosmic ray flux right now from about 7 different monitors. There's Oulu, Finland. And Oulu, Finland is down over the past 30 days. DOMB Antarctica is down over the past 30 days marginally. DOMC Antarctica is marginally down as well over the past 30 days. Headed down south to Mexico City. Mexico City slightly down over the past 30 days. Headed a little further north and across the Atlantic to Greece. There's Athens, and Athens is, well, it's slightly down over the past 20 days. Some missing data there at Athens. We'll ignore that one. And lastly, Apatity and Barentsburg. So those are both down over the past 30. Not a real surprise there. And if we do see a significant CME impact, well, you can expect them to be down even more. So let's head to... oh my God, what my head is... Where's your head at right now, folks? I mean, are you seriously... Are you spooked of space weather? For real? You spooked of space weather? Good God. So yeah, it looks like sunspot number is going to continue to rise because I think we've got some unnamed groups in the northeast, possibly even in the southeast. So we will once again not have any setting sunspots, so the likelihood of sunspot number to rise or remain flat until tomorrow is certainly there. It looks like some growth is happening in the northern hemisphere, though, so expect at least a mild uptick in sunspot number once again, perhaps reaching up to around 150 or even slightly above that. So, yeah, sunspot number looking like it's going to be moving once again. Once again? Yes. So, next is energetic particles. We ain't got none. No SEPs, solar energetic particle events, and only one M-class flare over the past 24, although we have seen an increase in the overall X-ray output. The background output here has come up quite a lot over the past 7 days. There you can see it was down into a B3.5, B3.5, and now it's all the way up to the background of about a C2. So, that's the situation. Here's one of our favorite flare wavelengths. This is data just from today from SDO, 131 angstroms. And yeah, so we've actually got 3 spots where we could theoretically see a large solar flare. Let's point them out, shall we? Oh, we shall. Here at the Smash News Network, least busted name in news, we shall. Those spots are this group right here, this group right here, and this group right here. So those are the 3 places to really watch for large solar flares. And again, as this group in the northwest, as this gets closer and closer to the limb, it will become more and more likely to produce an X-class event. So that is the most likely spot for a large flare, followed by, well, really equally these 2 areas here on the eastern limb. It's a threefer. Now let's move to a solar system forecast. That seems like a good thing. And I've reemerged from the bunker. So here is your solar system forecast. That's where things will be on the 21st of April. Just about 1 month into spring. And there should be some interesting information for you to see in our meteorology forecast. We'll be talking about things like sea surface temperatures and Arctic ice. So here is our star chart. That's what's going on overhead. If you're up at before dawn, you may see Venus and Mercury. If you've got a low horizon and low light pollution and clear skies, you might see the fastest planet, but be fast. It won't be there in the morning sky for very long. Continuing on to our astronomy picture of the day, and it's just spectacular. So that is the diamond ring effect, and we've got this thing on loop because the diamond ring effect. So first you're getting this bead-like effect because the surface of the sun is bumpy. The surface of the moon is bumpy, for that matter. So, and then you get the diamond ring effect. So, now of course, some people may think, oh no, a crazy, spooky solar flare's happening and the moon is just protecting us. That's just the sun emerging from behind the moon as the totality ends. That is what you see, depending on what kind of telescope and filter and so forth that you're using. So, that imagery there, courtesy of David Duarte. Just fantastic. apod.nasa.gov to see Bailey's beads for yourself. Bailey's beads, not the kind sold in adult bookstores. Next is coronal mass ejections. And there is an earthly directed one. It's quite stealthy, and that's what happens when a thing is moving directly towards you and is kind of gaseous. It can be a little deceptive. Well, don't be deceived. Don't be deceived by people who are peeved that we bring you the world's most comprehensive daily space weather content, because right in there you can see some ejecta looking like it's going off to the north while some of that ejecta is headed toward Earth. Because of where that came from, and well, that gives us an idea of where it's going. It's diffusing out into the greater solar system, and that is earthly directed. So you see that loop out of the west there? That's not earthly directed. That was early this morning. And then you see just a little bit of ejecta here coming out of the north and the northeast. Just right there, you can barely even see anything. Right there, that little bit of ejecta that you can see there, that is an Earth-directed CME. So multiple events happening there, and that can sort of mask other events. Let's show stereo A also. So there's that western CME, and then you're going to see a second event right there. Right there. See that ejecta right there? That is part of an Earth-directed coronal mass ejection. So what is that? 1209 at 1209. There it goes. And I should say here it comes, as part of it is on the way. So let's go to our custom coronagraphs. We've got some limited coverage today because of some kind of mistakes that happened. I don't know whose fault it is. I'm just going to blame Smash Staff. Smash Staff, that's 20 demerits. So that CME came from this active region right here, and you're going to see ejecta kind of moving in this way. But ultimately, it ends up kind of going like this way. But keep in mind, these things can make huge turns, as that one turned probably 70 degrees. But it's been on its way out the whole time. So you can see limb darkening. If we zoom in one layer here, you'll see material making its way up here to the northwest, toward the upper right of your frame. And yeah, that is a perfect example of quite an interesting series of activities going on today. If you want to make your own, check out helioviewer.org. That's where we get our... There it is. There's what you'll see if you create videos over there at helioviewer.org. And yeah, multiple CMEs. And if you notice, yesterday's video, we said there's just about 100% chance of coronal mass ejection. So we weren't really expecting one to be earthly directed, but hey, you can't really forecast a thing like that until it happens. It's pretty chaotic. So, now, here is the filament scenario, and we've got less than we did yesterday, but still a lot. So prominence down there in the southwest and the southeast and the northwest. But take a look at that. I mean, that is still a large number of filaments. So once again, the likelihood of CMEs into tomorrow is just this side of 100%. I mean, those magnetic fields are not static. They're not just going to stay there and just hold those filaments up forever. Filaments either relocate, collapse, or eject. Those are the choices. Those filaments are unsustainable. So that's the scenario. And let's get the bonus features. But first, the last couple of hours from the GO 16 SUVI. Again, a rising likelihood of large solar flares from that upper right, the northwestern quadrant. From that sunspot, it is the most magnetically complex. Here come bonus features, starting with charging hazards. We ain't got none. It's smooth sailing. GO's electron flux in a normal operating range. Nothing to write home about. There's the 1-year graph, a little bit higher than yesterday, but again, in a nominal range. And here's the expectation of a dip in the electron flux. That is from the expectation of incoming space weather. So far, we ain't got none. But if we do have a CME impact, we'll have a good signal. And one of those signals will be erroneous readings in the electron flux, marked by erroneously low readings as the ionosphere puffs up. Speaking of which, here's the F flare, which is at about 300 kilometers of altitude. There it is. The ionosonde from Australian Government Bureau of Meteorology. And if you're wondering if the ionosphere is going to kill you, the answer is, well, absolutely not. Although it does filter out the extreme ultraviolet that the SDO uses. Part of the reason why it's in space, so we can see the features that we observe in the CGI realm of extreme ultraviolet electromagnetic radiation, frequencies that aren't visible to the naked eye or from the ground level. Here's our anomalygram. That's anomaly in megahertz from a 30-day median. And hey, there ain't no space weather, so it's pretty chill in the ionosphere. That's a global ionosphere nowcast. And yeah, total electron content, maximum usable frequency. We'll close out space weather with the latest high-res images. Come on, then. Press refresh, and there you go. Now you know that they're fresh. So this one is it beta, gamma, delta class? I've got my fingers crossed. I've gone the wrong way here. There we go. I think it's beta, gamma, delta class. It's beta, gamma class. Doesn't look that exciting. This one up here looks quite exciting. Let's take a look at that. Not really. Just a lot of South Pole umbrae trailing that North Pole umbra there. It's just, it might only be beta class. Beta gamma class at the most. Anyway, here's your full disk. This one here is starting to look a little promising too. It's got some magnetic shear there in the middle. So that's always a good sign if you're hoping for solar flares. And if you're frightened of solar flares, I don't know what to tell you. Enjoy your cult experience. Next, our meteorology segment, because here at the Smash News Network, least busted name in news, we don't just bring you the world's most comprehensive daily space weather content. We bring you meteorology content because it's so darn easy when there's so much data, it's practically cheesy to forecast Earth weather. So anyway, looking at sea surface temperatures here, and the Arctic is 1 month into spring, still kind of frozen. There's the North Atlantic. And that's sea surface temperature and ocean currents. Let's show the whole planet. There's Antarctica, which is probably rapidly freezing once again. Here's our Indian Ocean, quite hot around the equator. And look at how hot it is around Papua New Guinea, Indonesia. Also, Fiji and Tonga, pretty warm there. And there is the mighty Pacific. All right, here come regularly scheduled meteorology segments, starting with the jet streams of the eastern world. Shout out to our viewers from the east side. Here are your surface winds. Shout out to our viewers from the central side. Here are your jet streams. Shout out to our viewers from the Americas. There are your jet streams. I don't know if you own them or not, but there's a huge low in the North Atlantic. Don't get frantic. And definitely do not get on a boat with Marky Mark Wahlberg and George Clooney, because there's nothing worse than seeing hunks drown because of the perfect wave. Here's our satellite map, and we're showing the visible satellite because it's just freaking so sweet to be making these videos during daylight savings time. Ah, yes. Daylight savings time. Let's have it all year round and throw this standard time nonsense in the garbage. Or I guess just have standard time all year round is really the actual solution. But yeah, there you go. There's a CGI Earth taken with digital photography, which makes it CGI. It's computer-generated imagery, right? Just like every digital camera in the world. And one of the stories today is heat. Look how hot it is in Kansas, over 90 degrees. Salina, 93 degrees. Dodge City, 91. Wichita, Kansas, 88 degrees. Oklahoma City, following suit. 89 in Haskell, Texas. It is a major warm spell. Check out some of the temperatures in Mexico here. Over 100 degrees in parts of Mexico. And let us know if anybody that you've seen on the internet has been cherry-picking data, trying to make the planet look colder than it actually is. I like the craziest thing is people say the planet is cooling down and these hot temperatures, they're a result of solar activity. Even though the sun is they'll tell you the sun is shutting down, which is making the planet colder, but the planet's hotter. So I think they might be refuting themselves. I told lots of people back in 2018 and 2019 that you may not want to claim it's a grand solar minimum until you see 2-week solar cycles in a row. So you got 0-week solar cycles in a row, which means you're at least 20 years out, more like 22 years out from being able to say it's a grand solar minimum, because you got to have 2-week cycles in a row, and you've got 0. So I don't know. Here's our weather.gov map. And yeah, let us know your favorite cherry pickers. As I see people saying some of the stupidest stuff, I mean, how are there as many cults as there are? How are there as many cults? I mean, people do not know how to do research. That's for sure. Anyway, we're scrolling down to show you the key. And check it out, some heavy precipitation there striking Hawaii. Some flood watches there. And some wind kicking up, so let's do some forecasts. First, pressure and precipitation. Now you're going to see some bars get very close together there. That is the sign of, well, it's usually associated with massive winds because it means you have a huge pressure gradient and the atmosphere wants to reach static equilibrium. So anyway, there's pressure and precipitation. A low will form over New Mexico and then make its way up to the Great Lakes, where it will cross Michigan and into Canada around Lake Huron. Next is our that's a GFS 72-hour jet stream forecast. Yeah, the jet stream. It's the culprit for your weather, as it brings more lovely warm air into the eastern Pennsylvania. Ah, how sweet it is. Just good times. I love a nice mid-April with nice temperatures. I'll take it. It would be nice to see the Lehigh Valley dry up as it is flooded like all over the place. It's berserk. This is our this mean sea level pressure and winds. And like I said, you're going to see some major winds developing there over especially New Mexico. So we're showing surface winds just for that reason. Mainly, it'll also get very windy over the Great Lakes when that low makes its way up there, as you can see, starting with Michigan and so forth. Well, anyway, there's the map. Temperature anomaly is next, and I'm going to have above average, back to average, and then back to above average in the mid-Atlantic states. Meanwhile, the southwestern U.S. is going to have some wild variations of both below and above average, as well as the Pacific Northwest. So some big gyrations there in your temperatures according to the GFS 72-hour forecast. Keep in mind temperatures there. Temperature anomalies shown there in degrees Celsius. And we've got lightning, and it's pretty calm as far as lightning goes. South America has some. But let's see what's going on. We do have some lightning here in the U.S. over western Pennsylvania. So a bunch of moisture has been evaporating out of the Great Lakes because it's so warm, and we've got some basically lake effects rain. So the same mechanism that causes lake effects snow, folks. Winds are accelerated across the lakes, evaporation happens, and then you get moisture and you get pressure gradients, and then you get water droplets. By the way, if you enjoy the content, press the like button. If you're new to the channel, press subscribe, because if you don't get to see the world's most comprehensive daily space weather content directly on your YouTube subscription, then that's on you. You can press the subscribe button. Don't worry, I'm pretty sure you can handle it. And press the comments if you're new to the channel. And don't forget to hit us up on social media. Visit the links below the video. Support the channel. Pick up some merch. You get some merch that'll do things like define words for you. Like that word. Some people say it as a verb. You want the real definition? Check out the Redbubble shop. There's all kinds of words of wisdom in there. Thanks to our subscribers, the Smash team, and even to Smash staff. We'll close out with Doppler radar as heavy precip shows up at Honolulu, but especially whatever that island is. Kauai. Kauai just got kaplastered. Kauai is getting kaplastered. I don't even know which way it's moving. Anyway, that's radar.weather.gov if you want to check it out yourself. We're focusing on the lower 48. And to be done making this video would be great, so we can upload it to your screen. There's our visible satellite. And there is our water vapor map. Again, rapid cloud nucleation, rapid evaporation happening from Lake Erie, driving that precipitation in western Pennsylvania. Here is your recap: U.S. Doppler radar, ground-based systems, space-based visible satellite, and let's don't forget the water vapor map. And here's me signing off. By the way, if you want to pick up a shirt just like this one, I'm a collector of Hawaiian shirts, by the way. Check out the Amazon shop, amazon.com/shop/Smashomash. But in the meantime, I'll have been your host, Dan, a.k.a. Smashomash, signing off. And while I'm gone, may that solar wind be at your back. S-bars, don't fail me now. Whoa!